So thanks for the reminder. I appreciate that. All right. So recording is in progress. Cool. Okay. Where I was, what I was discussing. Okay, so this is the module part, and let me open up the book because we are covering the material from the book now. Where is the book? Somewhere residing. Normally have it here. Yeah, there. By the way, slides, and if you guys have got time to have a look on the slides and book is almost the same thing, right? So they are on the, because they are designed for this book. So whatever you follow, they are exactly the same thing. Slides are really, in detail. So whatever you follow, it's good. All right, so we are on this chapter number 7 for the stack. And today we will discuss the applications. There are many applications specifically in the field of mathematics and algorithm itself. Stacks are used extensively. So let's start with the examples application. So here they discuss evaluating arithmetic expressions. We talked about that, in a brief way yesterday, that mathematical expressions, I mean, there are many websites, Wolfram Alpha, if I really remember. This website I used a lot during my PhD work. So this is a this is a very good website where you give a complicated kind of formula, and then this website computes the result for you. Really complicated. So this is a really advanced kind of website, from Alpha, Computational Intelligence. So so this is actually based on computing the results of formulas. But I told you that as a human, it is, it is really, it's not that hard for computing the results if we know, the basic of mathematics. So for example, if someone gives us a formula like this, so I can quickly compute the results because I know some of the basic rules are that division and multiplication has the highest precedence, and then plus and minus have the next, they come at the lower precedence. So they have lower priority, but division and multiplication have, higher priority. So whenever these operations occur, we have to perform these operations first. However, whenever the parentheses come, the precedence doesn't matter. Whatever is in parentheses is computed first, no matter what is the actual precedence of the operation. For example, 2 plus 3 has plus in them, but they come inside parentheses, so it should be evaluated first. So as a human, we can see it quickly and we can compute the result for this part, and then we know we need to multiply it with 4, and 5 multiplied by 4 is 20. We can compute this result. But for computer, it is not that easy, because for computer, everything is a character. Everything converts to 0, 1, some number on the back end. So everything is same for computer. So we really need some way so that computer can, evaluate the expressions, mathematical expressions. So there comes the role of stack, because stack really makes the task easier for us for evaluating such stuff, mathematical expressions. This is one part. Okay, by the way, I missed one one notation. Where is that notation? Okay, this one. So this is exponent. When we compute the power, for example, 2x exponent 3 means 2 times 2 times 2, okay, which is 8. So this operator has the highest precedence in mathematics, and then come these operators come division and multiplication, and then plus and minus. So in this way, we compute this is the order of precedence for operations in maths. All right, so we can definitely find the result quickly by knowing some of the basic rules, but for computer, it is hard to understand this type. Actually, it's not hard to understand. Instead, I would say differentiate among them. What is the difference between this steric and for? So for computer, everything is a character, or everything is whatever we are typing from the board is an input. So what is the difference between that? We have to tell to the system. So here comes the role of stack. So what stack does? Um, You might be surprised by the difficulty of writing an algorithm to evaluate arithmetic expressions. Yeah, because it is an advanced kind of, problem. So it is going to take a couple of steps. So it is not that, quick solution. So it turns out that an indirect approach to the problem works best. So in this approach, whenever we are working for evaluating a mathematical formula by computer, we need to transform that expression into a form which is called postfix. So infix form is something which we use. This is infix. Infix means operator comes in the middle between these both operands. So 2 and 3 are operands and operator is plus. So plus is in the middle of 2 and 3. So this is infix notation. Everything is infix. So when I have 5 here, 5 will be multiplied by 4. So 4 is on the right side, 5 is on the left side, middle part is the operator. So this is infix. So by default, our mathematical notations or expressions are infix form or infix expression or whatever you can say. This is infix notation. So this infix form or notation is converted to postfix for computer to evaluate the formula or expression. Okay, the same thing. So we have postfix means we have operands first and then the operator comes. So that kind of notation is, somehow difficult to read for us because we generally understand infix quickly. But postfix is a better form for computer to understand. You will see whenever we will be working on this today that how, because it is not, quickly, I would say that you are not going to grasp it quickly. It is going to take a little while and then you will be able to understand the concept. So postfix means operator comes after the operands. And once infix expression or form is converted to postfix, then computer can evaluate that form for computing the result. So this way, computer can easily, compute the result. How? Using the stack. I mean, maybe we can design another solution without stack that can be, kind of more complex in terms of coding, but the best way is using stack. So in infix form, each operator, as we discussed, is located between operands. In postfix, operator immediately follows the operand. So both operands come and then the operator comes. So let's see some of the examples. For example, infix, there is an evaluation or expression, infix evaluation, 34 plus 22 times 2. So if I compute the result for this, I know that 22 times 2 will be multiplied first because multiplication has higher priority, right? Higher precedence. And then the result will be added to 34. So we get 78. For postfix valuation, we have this stuff. So this is better understandable by computer for evaluating the result, for evaluating the expression. Computer doesn't have to work on the precedence part. Instead, computer will read the expression and it will compute the results if it is in postfix form. How? For example, we have 34 here. and then we have 22 and 2. Okay, and then we have star and plus. So basically we compute this part first. The computer does that first. How that there is a procedure, there is a code for that using stack. So the values are pushed on stack, then they are popped from stack, and then we get the result. But currently we are discussing the concept, the idea. Okay, so postfix valuation. First of all, we convert infix to postfix. This is one step. This is one separate program. Then we do the evaluation in another program. So 22 and 2 are multiplied. So this part is gone because we get 44 from it. And then we get 44 right here. So we have 34 and 44 side by side with an operator which is plus. So the result is added. So why it is simpler for computer? Because the things are pushed on stack and popped from stack. So the results are computed, in a good way, in a simpler way, I would say. So this is how it looks like here, but let's go ahead and see a little bit more. Oh, they have more examples. So this is really, similar. Two operands are this 22 and 2, which comes here with a steric, but then whatever the result comes, that becomes a separate operand. So that operand is then added with 34 because there is a second operator to operate, which is plus. So first of all, multiplication is done, then a plus is done. Okay, but the order changes whenever we have parentheses. Okay. So a different result for the same expression whenever we have parentheses. The same, okay. The same expression with the only difference that we are putting, parentheses there. So parentheses have higher priority. So which means plus should be done first. So that's why you see a plus right here, which means 34 plus 22 will be done, and then it will become first operand. Okay, and that operand will be multiplied by 2 using this, steric. So now it looks a little, different. I mean, this is really kind of a strange form which we are saying here. But the thing is, first, if we know the rules, how to convert infix expression to postfix, then we are good. Then we just don't bother about this part, this postfix notation part. Because we know the rules, we will write the algorithm, and then we will implement that algorithm. So infix form will be converted to postfix. So which will be input for computing the evaluation, final result. So that these are the actual steps which we will go through today for some of the applications of of stack. But then there comes parentheses. Parentheses have higher priority. So another problem comes. For example, someone inputs like this in computer to your program, which is doing evaluation. I'm inputting something like 2 plus 3 like this. Now this is a wrong expression. So now computer has another task to do. So it should identify if it is a valid formula or not, if it is a valid expression or not. If it is not a valid expression, we cannot evaluate that unless you correct it. So this is not a valid expression, which means the next step comes. For example, I write a formula like this. Okay, and I put some numbers there. It's okay. 4 divided by 5 and 6 multiplied by 7. The only issue in this part is there is an extra parenthesis. So if I remove it, it is okay. So such formula which has no problem in it before evaluation or before converting that formula to postfix. So such formulas are called balanced forms or balanced expressions, actually. Not formulas, balanced expressions. If there is something unbalanced, for example, I'm putting 2 extra parentheses which have no opening, just 2 closing parentheses. So this is unbalanced. So which means we should be able to write a code which identifies if an expression is unbalanced. So first of all, your expression should be balanced. Then expression should be converted to postfix. And then if we want to evaluate that, so that should be the next step. But first we get the postfix. All of these applications will be using stack, the stack what we have built yesterday. Okay, so if I stop me if at any point you are, you are not comfortable with the concept. Okay, so they are starting with evaluating the expression instead of discussing how postfix is made, computed or calculated. Okay, that's fine. So these are the 3 steps, only 3 steps. But for that, you need to convert your infix expression to postfix. We will do that part. But let's just quickly go through whatever this says, how to evaluate. So we assume we have infix form, which has been converted to postfix already. And now that postfix form is being used for evaluating the result by your code. Okay. So we will scan across the expression. Okay, of course, we will read the expression from left to right. This is the way how mathematical formulas, go from left to right. On encountering an operator, apply it to the 2 preceding operands and replace all 3 by the result. For example, very simple. Let's start with this part. So where is the post? Okay, this is the postfix. So the rule is go from this side, keep going. You find operator, pick the operator, which is steric, apply it over the 2 preceding operands, which is 22 and 2. So the result will be 44. Okay. So replace these 3, elements, 22, 2, and steric with 44. And then again, do that. So again, you will go 34. You will be having, 44 and a plus. So the rule is whenever you find an operand, operator is a plus. So you have to apply that operator on the previous operands. And in this way, you will be, able to get the result. Okay, so this is what they say here. Scan across the expression. On encountering an operator, apply it to the 2 preceding operands and replace all 3 by the result. Okay, fine. Continue scanning until you reach the expression's end. And it means you get the final result. No more extra operands or operators there. So this is done using stack. So what they do, they have written a pseudocode for that part. To express this procedure as computer algorithm, you use a stack of operands. In the algorithm, the term token refers to either an operand or an operator. So whatever you encounter as a whether it is a number or it is a parenthesis or it is an operator, everything is considered a token here. Okay, so token. So create a new stack. Let's see how the code is done, and then we will discuss our own code as well. So create a stack. I just want to show you that these 3 steps are, are based on the stack here. So we have a stack, create a new stack. While there are more tokens in the expression, keep picking the next token from the expression. So get the next token. If the token is an operand, okay. If it is an operand, which means let's forget about the parentheses. If it is an operand, which means it is a number, okay, push the operand onto stack. So here the stack comes. We are pushing one operand. We saw one operand, we pushed that there. We saw another operand, we pushed on the stack. But if the token is an operator, if there is an operator, then pop the top two operands from the stack, apply the operator to the two operands just popped, push the resulting value onto the stack. Let's see it somehow on the board right here. Understanding of that is really important because we will be covering part of the coding. I mean, we will be using these kind of applications today in the code. So let's just do a refresh. That's a better. So for example, we have a stack. So this is a stack. Stack may contain, operands, only operands. Okay. So let's follow the same example. That makes the things easier. Okay, so we are assuming Infix formula has been converted to postfix already. So let's pick this example, 34, 22, 2. Okay, where it is 34. How it will be converted, we will work on that. Okay, so don't think much on that part. What was that? 34, 22, 2, multiplication and plus. Let me just see. Yeah, okay. So the idea is whenever, okay, start from this point, you found an operand, 34, push it on the stack like this, okay? Then you went ahead and you again saw an operand. So you pushed 22 over there. You found an another operand too. You push that on the stack. So everything comes on the top. So this is the stack top right here. Top. No more operands. So this is the top. Then there come the operators. So I get the first operator, which is static. Whenever we encounter an operator, we will pop two operands from the stack. Pop means remove them and apply the operator and compute the result. Okay, and then push this result on the stack. 44. I don't know if I'm correctly. 22 times 2, 44. Yeah, okay, good. All right. All right, okay. So now again, go ahead. You got another operator, which is plus. Same steps. Now the top is right here somehow. So remove the operands, two operands from the top. So one is this 44 and the other is, down there 34. So this part is no more in stack. So we just have two operands, 44 and 34. So we will pop them out, 44 and 33. Two-time pop function will be called. 44 and 33 will be in our, in our store, in our variable at some point. And then we will apply this operator plus. So plus will be applied to 34 and the final result will be 78. So this is the result. So this is how in a postfix expression is evaluated. So basically this is how a mathematical expression is evaluated by stack. Okay, so this is the algorithm and this is the pseudocode for that which we applied. Not that, kind of complex. Okay, so this is part of your, one of the application. Go ahead, we have to work on the part. First, we need to convert infix expression to postfix. Okay, so let's cover, we are going to cover that part too, and we will implement that part as well. Okay, let's see. Oh, so they are discussing time complexity of algorithm is big O of n. Yeah, because there should be a single loop. We are iterating over the expression. So it's kind of a single loop. For example, there are n total number of, tokens, n number of tokens. So complexity of the algorithm for evaluating will be big O of n. So that's the worst possible, worst possible complexity of this algorithm. Okay, so now, okay, so that's the exercise. Yeah, now the question comes how to convert infix to postfix. So you learn how to translate expression from infix to postfix. For the sake of simplicity, you can restrict your attention to expressions involving operators. Okay. As usual, multiplication and division have higher precedence, addition and subtraction have lower, except when parentheses override the default Bayesian, Bayesian rules. We know that. So now they are discussing, I think what they are discussing here. I believe this is for infix to postfix, right? Yeah. So these steps discuss infix to postfix conversion. So we will do that in the code. So I will discuss it from here. First of all, we will cover this part from the book, and then we will implement it in our code as well, right? Okay. Start with an empty postfix expression. We don't have any postfix, we have infix. So we are going to convert infix to postfix. So start with an empty stack, which will hold operators and left parentheses. So this is good that they are involved using the parentheses because, mainly our mathematical expression use parentheses, right? So the algorithm first step will be, what we will push, start with an, yeah. So your stack will hold operators and left parentheses. We will scan across the infix expression from left to right, okay? On encountering the operand, whenever we encounter a number, which is an operand, okay? Append it to the postfix expression. Don't push it on stack. The rule or algorithm is put it in the, or not put it, append it. Append means at the end. Put it or append it in the postfix expression. So initially postfix has nothing. So whenever you found an operand, add it into postfix expression. On encountering a left parenthesis, push it onto the stack, only for the left. Okay, we will do it. So in the coding, it will become easier to understand. Right now, there are certain steps because I have to write it in the code. I want to make sure that you have some idea instead of when I will be writing the code and you will be so much, I don't want to, create trouble so that you understand at least something before. So on encountering an operator, pop off the stack all operators that have equal or higher precedence. This is important. So again, whenever you see an operand, put it in expression. That will not go into the stack. Stack will only hold your operators, which means plus, minus, division, or multiplication. And then parentheses, only left parentheses, which is the opening part. Okay, that part will stack is going to store. So whenever you encounter an operator, then pop off the stack all operators, because your stack contains operators. It will be containing operators. Initially there will be nothing, but you will be putting operators there. But whenever you encounter an operator, check your stack using peek, because peek can tell you whatever is there on top, right? So pop off the stack all the operators that have equal or higher precedence. If the operators in stack are equal, whatever the new operator is coming, or they have higher precedence, whatever is in the stack, then pop them out and append that part into the postfix expression. And then push the scanned operator onto the stack. So basically, this is kind of the the only kind of complicated step in this algorithm. So the idea is, this is your stack. We are converting infix to postfix. We are going to implement that. And I really want to make sure that you understand this concept so that code looks really simpler to you. Okay. This is the idea. So that's why I'm putting more time to make you understand the actual algorithm. So this is your stack, which will be holding left parenthesis. As whenever left parenthesis come, you will push it on the stack. And operators. By the way, your book has a couple of examples for this algorithm, mathematical examples with expressions. So we will go through that as well. So plus, minus, division, multiplication. So this part will be on the stack whenever we will be reading infix expression. So for example, we have infix expression here. Let's use the same expression. Okay, I don't know whatever the book is using. Okay, let's go with that. 4 plus 5 multiplied by 6 minus 3. This is an infix expression. We have to convert that to postfix. Okay, so 4 plus 5 times 6. Let me write it here. Is there times 6 minus 3? Okay, so this is an infix expression. We have to convert it to postfix before evaluating the final result. Okay, so we will start from here. Okay, so the rule is where let's go back. Okay, so we have an empty stack, an empty, postfix expression. Scan across. Whenever you encounter an operand, append it to postfix expression. This is the first step. Okay, so if I go back here, so let's make an operand, postfix expression. So initially, postfix expression has nothing. It is none. Okay, but whenever we read from here, so we have 4. Okay, so what I will do, I will put into my postfix expression a 4 because this is the operand. Okay, so we will push only operators and left parentheses on stack. So 4 is an operand. So add it, append it into your postfix expression. This is the first step, right? We don't have any parentheses, so forget about that. On encountering an operator, pop of the stack all operators that have equal or higher precedence. Okay, so this is kind of, I think, better understandable from here. So we encounter 4. Postfix expression has 4. This is what we are doing right here on the board. So postfix expression has 4, stack is empty. But then we encounter plus. So the step will be add this plus here. Push it on the stack. Right here. Okay, push it on the stack. Then okay, another number comes 5. So we have to append it on the postfix expression. So basically we are putting some data on stack and some data in postfix expression. So let's follow this. This looks better, I believe. So 4 is here, and then we encounter plus right here. So this is our stack. So stack has plus, just like we have on the board. So we have plus here. Okay, push plus onto stack. Right, then we did the next part. After plus, we find a 5. So 5 is an operand. Okay, so whenever I told you, whenever we find an operand, we have to append it onto in the postfix expression. So postfix expression is this. So we found 5. Append it. Append means put it in the end. So right here, it becomes 45, 4 and 5. Okay. And after 5, we get multiplication, which is again an operator. Now we have to check the stack. This is a really important step. So steric has higher precedence. Okay, right? Now the rule is, whenever you get an operator, you have to go to the stack for pushing that operator. But make sure whenever you go to the stack that you have to pop of all the operators that have equal or higher precedence. So which means if your stack has any operator which has equal or higher precedence, whatever you have in your hand at that time, whatever you are reading from the expression at that time. So in that case, append them to the postfix expression. Pop from stack and append in the expression. But in the example here, what we encounter, so this is a little bit, it will take a little bit of time to understand, but once you understand, it's all good. So we are right here. We got static. So we got an operand. Our stack has plus. This is plus. Our postfix expression has 4 and 5. So whenever an operator comes, we have to check the stack. So we check the stack. So stack has a plus, but what we are reading from in expression is static. So we have to see if your stack operator, whatever is in your stack, which is a plus operator, okay? So we have to see if it has equal or higher precedence. So plus has equal or higher precedence than this static? No. So we are that rule is kind of we are kind of out of that rule because plus has lower precedence, which is in the stack. We have to pop the operators whenever any operator comes in the expression which has, whenever we compare that operator with the stack operator, so the stack operator should have higher priority or equal priority. But in this case, we are encountering static and stack has plus. So plus has lower priority, not an equal priority with multiplication, not higher priority than multiplication. So which means whenever we are at this in this situation, we are not popping out anything from stack. Instead, we will push it on the stack, that operator, because multiplication is coming ahead in the formula and multiplication has higher precedence, plus has lower. So we are not popping anything out. And this is what this line says. On encountering an operator, which is multiplication, we are on multiplication, pop of the stack, all operators that have equal or higher precedence. Your stack only has plus, and plus has less precedence than multiplication. So we are not going to follow this step. Okay. We will whenever we don't follow this step, it means we will push the operator on stack. Okay. So yeah, push the operator on stack. So we pushed multiplication on stack. So multiplication is on top, plus is on the second. Okay. Postfix expression is same. Push static onto the stack. Good. Now, after static, we found 6. 6 is a number. So what we have to do for 6, whenever we found an operand, we have to append it to the postfix expression. So we are building this postfix expression. We have 45, 4 and 5, sorry. So we found 6, we append right here in the postfix expression. So your postfix expression has 4, 5, and 6. Good. After 6, we encounter, okay, now this is important. After 6, we encounter another operator, sorry. This is minus. Now check your stack. The same rule. Check your stack. Okay, wow, your stack is, different. So this is our stack. We found minus. Now compare, if in your stack, we have to pop out all the operators from stack who have higher precedence or equal precedence to the operator which we are reading from infix expressions. We are reading minus. Compare whatever is in the stack has higher or equal precedence to minus. Does it make some sense? We're following this part. On encountering an operator, pop of the stack all operators that have equal or higher precedence, append them to the postfix expression. And then whatever you were actually having in your expression, a new part from your infix expression, push that operator on stack. So this is the real part of your code. Other stuff is easy. So let's see. We found minus. Now compare your stack operators. So on stack, you have static. First of all, see static, okay? Because your stack shows only the top part. So what you have on top, you have static. So compare stack and minus. So minus has lower priority, while static has higher priority. So whatever is higher on your stack, pop that out. This is the rule. Okay, pop that out, append it on the postfix expression. We are not removing that. We are popping it from stack and we are putting it right after. We are appending it on your postfix expression. So your postfix expression becomes 456 static right here. Ignore plus for now. After doing this static, we found another operator on stack, which is plus. We are comparing it with minus. So whenever your stack has operator which has either higher precedence or equal precedence, pop it out, append it on the expression, on the postfix expression. This is the rule. So minus has equal precedence with plus. Your stack only has plus at this time because we have moved this static to postfix expression. Then plus is having equal precedence to minus with minus. So we will pop it out. We will append it on the postfix expression. So now our stack is empty. Doesn't matter if it is empty, but plus and static are gone to the postfix expression because the lower precedence or, another operator is coming, which is minus. So that minus will be pushed to stack. So your operator stack just has minus. However, your postfix expression is this. Let's see what else. We have 3 here, the last part, 3 in the expression, in infix expression. So on encountering 3, whenever we encounter operand, what we do? We append it on postfix expression. So what we found? We found 3. This is an operand. Append it. We appended it right here. You see that append 3 to postfix expression. Now, almost done. Whenever your formula, your expression is ended, then what we have to do? We have to pop everything from stack and we have to append it right here in the end. That's the final step. So our stack has minus. So we will pop it out from stack and we will append it in that postfix expression. So this is the final conversion of postfix expression from infix to postfix. I mean, there are a couple of steps. I totally agree. It looks maybe, complex, but while we will be coding, you will see that it's not that, that big code. And we will be following exactly the same lines of code. And the thing is, whenever you go through the examples, that really, make the thing easier. So I really prefer that if you want to understand, and okay, so the good thing is that they have an example for parentheses as well. So I told you that opening left side, go on the stack, okay? Yeah, opening part, which is the left parentheses, also they are pushed on the stack, not the closing, okay? So, I mean, this is how the algorithm goes. And they show that because there is an opening, what they do, push it onto stack. Then somehow, okay, let's take a break, give your mind some kind of relaxation, and we will follow this example. After doing this example, we will cover the coding part. Okay, we will move towards coding, and then we will go, well, we will do the coding stuff. Um, so I really want to make sure that the examples are, understandable by you, and then we will be able to implement this. Okay, so we will cover this example after a 10 minutes break. And the example is again following these steps 1 to 7. Okay, so let's take 10 minutes. And then, meanwhile, if you have any questions, gather them, think about that, and then you can ask me right after the break, okay? Okay, so, all right. So we were on the example. So let's explore this example before moving forward towards coding. So this is an infix expression with parentheses, which is good. So our stack is for operators and for left parentheses. Okay. So we encounter the first left parenthesis. We are reading the expression from here left to right. So push it on the stack, onto the stack. Okay. The next is 4. So this is an operand. So whenever we encounter operand, we have to put it, append it on postfix expression. So we have appended it on postfix expression, which is like, which is having nothing earlier, but now it has 4. Okay. Now plus comes. So whenever operand comes, we have to push it on the stack. So we are not checking it with any other, because stack has no other operators. Okay, so we just push it right there on stack plus. Then we encounter 5, so it will go to, expression, postfix expression on the end. So it becomes 4, 5. After 5, we encounter what? We encounter the right parenthesis. So on right parenthesis, we are not doing anything. Where is that? Okay, append 5. Okay, so when right comes, yeah, so whenever you encounter the closing part, so it means one part of your formula, of your expression is, kind of completed. So whenever we encounter first and one and closing, one closing parenthesis, so what we have to do, we have to pop the stack. We have to pop everything from the stack until we encounter the left, so that, they are kind of matching things of expression. So what we do, because it sets the precedence, so we really have to take care of the parentheses. So the left part goes on the stack, and whenever we see the right part, which is the closing part, so what we do, we pop, where is that? Pop the stack until the opening parenthesis is encountered, and append operators to postfix expression. So in this way, the precedence is managed, that this part will be computed first. So whenever we encounter closing, we don't put closing part or opening part into postfix. Postfix has nothing, no parentheses. Instead, it organizes the operands and operators in the way that the computation is done in the precedence, in the order of precedence according to the parentheses. So whenever first parentheses come for the closing, which is the right parenthesis, what we do, we pop the stack until the opening parenthesis, which is the left parenthesis, is encountered. So on our stack, we have this part, we know. So what we do, we pop everything from stack until we encounter the parenthesis and append whatever is on the stack to expression. Not the parentheses, not the left parentheses, all the operators, if whatever the operators are there. So far we just have plus. So we will put plus right in your postfix expression, and then we just don't bother about the that parenthesis. We have removed that, popped that from from the stack already. All right, so yeah, so stack is empty because we have removed whatever was there so far. The next part comes, which is static. Again, we have to push it on the stack and check the stack if there is any operator having higher precedence, all that particular rule. So stack has nothing, so don't bother about anything. Static will be pushed on stack. Expression will be same so far. After static, we encounter again left parenthesis. We have to push it on the stack. Then we encounter 6. So 6 will be appended on the postfix in the postfix expression. So let's see. Yeah, it is there, opening is there, and then we encounter 6. And when we encounter 6, so it is appended, we append it right here in postfix expression. After 6, we encounter minus. So now it is kind of an important thing. So minus comes here. Okay, so you have to check the stack. Your stack has these, these values so far. Opening parenthesis is there. Okay, so when minus come, it has. We have to check the parenthesis part in our where they are discussing about the on encountering a right parenthesis shift operators from stack. This we have done. Okay, so they didn't discuss anything about the. Yeah, okay. On encountering a right parenthesis, we have to move, we have to pop the things from stack and we have to put it on the postfix expression. This is what they have discussed so far. Okay, no problem. So here, whenever we encounter a minus, we were right here, right? Yeah, so minus is pushed on the stack because you compare if it is compared with multiplication, but multiplication has higher precedence. So if there was no like this parenthesis, which is opening part left parenthesis, then we will be removing the popping up the multiplication because multiplication has higher precedence. Okay, so right now the stack on top has no operator. Okay, no operator. This is just parenthesis. So we will skip that rule. Okay. So we got minus, that is pushed there. After minus, we get 3. So 3 is pushed right in postfix expression. It is there. After 3, we found right parenthesis. Now we have to pop the things from stack. So we found right parenthesis. What we do, we go to the stack. Stack has these elements. We have to pop elements until we found opening. So what we do in this step, we pop minus, we pop, this parenthesis out. So stack just has, multiplication. So minus is appended right here after the expression and, the formula expression is ended. After expression is ended, we have to pop all the elements from stack and append it on the postfix expression. So stack only has static, so static is appended right at the end. Pop the remaining operators of the stack and append them to the postfix expression. So this is your postfix expression where computation is done 4, 5 plus. This step will be done first, then 6, 3 minus will be done. The result of 6, 3 minus and 4, 5 plus will be, a single result. For 6 and 3 minus will be 3, 4, 5 plus will be 9. So 9 and 3 will be multiplied. So 9, 3 multiplied. So 9 times 3 will be 27. This is how computer will process it. But again, this is the first step. We have converted infix to postfix. After this, we have to do the evaluation. And for evaluation, whenever we started the lecture, we discussed the first thing about evaluation. So it has 3 brief steps, very simple. The evaluation is simple. The important and complicated step is this conversion, and we will work on it now. Okay. Yeah. So this is very core application of stack. And before implementing this application, where we convert infix expression to postfix, we will do 1-2 more examples so that we get used to of using stack. Okay. So let's implement some exam. I had VS. I believe that I had opened it. I don't know. Closed it. Let me just open up my editor. I believe it was open. Okay. Yeah. All right. So what we want to do, we want to create a new file. Again, we are using stack. So let me open up the stack file because we are using stack. So we implemented this stack yesterday. Okay. So let's use this stack. So it has name stack to do. By the way, it should have name stack, but it's okay for now, right? So this file name should be stack instead of stack to do. So from stack to do, because we are using stack, okay? Import everything. So static means import everything. Let's save this file. So very first implementation, which I want to do is parentheses checking. First of all, we should make sure that the formula is balanced, right? So there are a couple of steps. Formula should be balanced. Expression should be balanced. Expression should be in postfix notation, and then the evaluation comes. So let's do the parentheses, the balancing part. Okay, I call it what? Role as balancing. Okay, balancing dot Python. Okay, so we will check if the expression is balanced, which means these kind of whatever is there, everything is balanced. There is no kind of missing thing like this. So we have to make sure that this is the first step. So let's do that. So this code will check if an expression is a balanced expression. Okay, so after that we will convert it to postfix. It should be in steps, and then this code is also kind of simpler. So we start from here. All right, so we will be using stack. So let's make a method. You can give it any name, for example, balancer, not balancer, balance checker, like this. It will take something inside, some expression. Okay, and then, yeah. So we have to use, we have to read the expression by reading single character one by one, if it is a parenthesis or what. So what we will do, the idea is, do we have an example in the book? Let me just, I mean, we should have it somehow, not backtracking. Let me just say, oh yeah, it is there. Do they discuss the steps? No. Not here. Yeah, there. So a more sophisticated approach using a stack to check an expression if it is a balanced or not. So scan across the expression, push opening bracket onto stack, just like we were doing in infix to postfix. Okay, so push opening, which is the left parenthesis on stack. So whenever you encounter a closing, if the stack is empty, or if the item on top of the stack is not an opening bracket of same type, then it means the expression is not balanced. We can quit the loop. We can say the expression is not balanced. Otherwise, we pop the item off the top of the stack and continue scanning the expression. So the idea is that Can I? So for checking and evaluation, what I'm doing, I will be putting all the openings here. So whenever I will find a closing, I will see what is on my stack. I will pop it out and I will see if it is kind of, if it is the same thing. Like this is the opening and this is the closing. It is a matching pair. It means it is, a balancing part. If I keep on pushing these items, for example, I have this formula and I have to check this. In middle, we have some numbers. So I will push this on stack, the left parenthesis, then the next left parenthesis. I will again push it on stack. Then there is some formula, forget about that. Then there is a closing. Whenever a closing parenthesis come, we have to see the stack. We have to pop the element. So we have an opening here and we have the closing here. We see this is matching, but then the expression is finished, nothing else after that. However, our stack has one extra parenthesis left, the left parenthesis, so which means it is not balanced. So in this way, we keep pushing left. Whenever right is found, we try to pop from stack, then it becomes like a pair, push pop, something like that. And in the end, if the stack is not empty, it means it is not balanced. Okay, even in the middle at some point we can say it is not balanced. Let me just okay, yeah, that's right. Okay, so where is my code? You're right, we can actually make a class. It's okay. You can create a class here for like this, class tester, or evaluator, something like that. Okay, so this is our class, and in class we have a method. Okay, that's it. So up to you, whatever you want to work. If you want to design a method without using the class, it's okay. Otherwise, you can put it inside a class. Okay, that's fine. So let's define the method. Balance checker. So the rule is again scan. I'm writing it here. Scan across the expression. So if we find any opening parenthesis, we will push it on the stack. So I am writing a loop for character in expression because I have to read this expression, whatever the user will input. Okay. So for each expression, I have to check if character in, can I say something? Your expression may have more parentheses, something like that. Let me put a character. It can be this opening, it can be this opening as well. Okay, it's so okay. So far we discussed the parentheses, but your expression may have other, notations as well. Okay, so you may include this part. So whenever you have left, push it on the stack. If you want to keep it simple, just parentheses, you can leave it like this. Okay, up to you. Both ways. I mean, it's okay. So this is the left parenthesis. If your character from expression is from this, what we will do, we will push it on the stack. By the way, make a stack. Stack equals stack. Let's take a big size. Okay. Yes, for now it is 100 size is okay. After that, we will see what is a good optimal size for stack. Push it on the stack. S dot push. Oh no, stack dot push. Push like this. So we have to push the character there. If the characters are, opening part. Otherwise, else if it can be, it can be a closing bracket. Okay, we don't. I mean, we are not bothering about operator and operands. Okay, we're just counting and checking the parentheses. So else we will check if character is in, the closing part. If it is this, or maybe this. Oh, can I put it like this? Yeah. Then I have to pop. This is what we discussed, right? So if stack dot is dot empty. Okay, so if we encounter the closing part, and if stack is empty, so we are getting the closing part, and we see that there is nothing on stack. It means this is imbalanced. It means we got an expression which just has this kind of stuff, because there is nothing on stack which is matching, with your parentheses. So if stack is empty, you can return from here. You can print a message, or you can just return false, and then check that it is not balanced. Okay, false means it is not balanced. I can write here actually. If stack is empty at this position, expression is not balanced. So push and pop should match. If you are getting the closing and stack has nothing, which means stack has no opening for that closing part, closing parentheses, it means this is the formula, the expression is not okay. Other than that, we will pop the item, whatever is there, okay? Because if stack is not empty, there should be something. So let's pop the item. So pop item should be stack.pop, not peak, like this. So we are popping the items, and now we need to check. So now here we will check whatever item is popped. If the closing is parentheses, then opening should be parentheses. The popped item from there should be the same parentheses. So this is what we will check here. So I will write brackets or parentheses must be of same type. Okay, so this is what we are checking here. So if your character is, this closing, and your popped item is also the same thing. Okay, if character is this bracket and popped item is, popped item is not equal to this, so it means there is a problem. Okay, if you are encountering a closing parenthesis, closing bracket like this, so your popped item should have the same opening bracket. Otherwise, that is imbalanced. So this is one condition. But then we are checking parentheses as well. This is for bracket. So we will check if character is equal to this, and pop item is not equal to this. So it means it is imbalanced. So again, we will return false. I have put it wrong way. Okay, now it's good. Okay, return false. So in this way it will be false, in this way it will be false, otherwise it will be true. So I will be returning right after loop, return stack dot. Where is empty? In the end, stack should be empty. So if stack is empty and it is true, it means your expression is balanced. Okay. So by the way, you can return directly true here. It should be the same thing. Remove it from here. Let's try running this code. I'm removing that stack from top, and I'm pushing it right here. And we need to call what? Tester dot balance checker. This is the method inside your tester. Okay, so it takes an expression. So for example, I put something like this, 2 plus 3, like this. So this is an invalid expression. There is an extra parenthesis like this. So it should return false. It should return false. We can print a message here. If am I doing it? I should take an input for an expression. That's a better idea. Let me just do it here. So let's take an input. Yeah, that's better. Enter an expression from user. Let's ask the user. Enter an expression and enter the expression right here instead of changing it every time, right? So this expression user will enter like this. Okay, so if it returns, true, it means it is balanced. Expression is balanced. Otherwise, we can print that it is not balanced. Else, you can do the same thing in the method itself, right here, wherever we are returning. But unless the stack is empty, we don't know the complete result. However, if stack is empty at this point and at this point, we know that it is not balanced. But the balancing will be sure when we are at this point. Unbalanced stuff comes from this part. Okay, so that's why we are printing right here. Expression is unbalanced. Okay, right. Let's try. So by the way, a good way of making your stack is, okay, instead of 100, let's do whatever user is entering. If user is inputting exp, so let's make a stack of length of exp, right? So whatever the length of expression is, we are making a stack accordingly. I think that's better, okay? So whatever user enters, that for that many characters, your stack will be created. Both ways are fine, but this is like more general and better. If there is some problem, we will debug it. Otherwise, okay. So it says enter an expression. This output is from the class, from stack to do class. So if I enter an expression is unbalanced. So let's try it again. I mean, make sure that it is working for, I'm not putting anything in the middle. It is balanced. Okay, one more time with some numbers. Not here. 2 plus 3. 1 plus 4. 4 times 5. Okay, it is balanced. Basically, whenever it encounters operands and operators, it doesn't do anything, okay? Because we really don't bother about this part. We bother about the parentheses, if any parenthesis is missing, okay? So that's why it is working for the numbers. If you put numbers or you don't put numbers, it is the same thing. There should not be any issue. Okay. So how about if I return true here? Let me just make sure. Because in other cases, I'm returning false. Expression is balanced, okay? And unbalanced. Yeah, so it's up to you if you return directly true from here. Because false will be returned whenever it is unbalanced. Whenever some unmatching is done. Whenever, you encounter a closing and there is no opening because stack is empty. This is unbalanced. Otherwise, it will be balanced by the end of the loop. When it has done everything and it did not return false, so it means expression is okay. So that's why we directly return true from in the end. Okay, so what we did, we checked the expression for parentheses. Whenever we get the left parenthesis or left bracket, we push it. Otherwise, we check if it is closing. So if the closing is encountered and stack is empty, it is unbalanced because stack should have an equivalent opening. So that's why we check if the stack is empty, it means that is not balanced. Otherwise, if stack is not empty, stack has something, then we pop from stack what is on the top and check if that character matches with the popped item. Whatever we are getting in the character here, we are reading the expression. So we check that character if that character is matching with the popped item. Okay, so we got closing part for bracket, and our popped item was opening for the bracket, so it means we are good. But if it was not the opening for the for the bracket, it means there is a problem. Similarly, if you found closing part for parentheses, but your popped item is not the opening part on stack, you popped an item from stack and it is not an opening parenthesis, so it means again it is not a balance. There should be a matching thing. So this is an application that you can check your expression is your expression is balanced or not, which is the first step for evaluating an expression. Whenever we want to evaluate an expression, it should be balanced. Expression must be converted to postfix before evaluation. This is another step on which we will work and on which we talked about already from the book. Okay, so expression must be converted to postfix. So instead of getting into that, I will do another example, a small example for stack application. I mean, not an exact stack application, but an example where we can use stack. Okay, so let's make another. By the way, if you have any questions in this balancing part, where is the book? Yeah, so this balancing method we are using. On encountering a closing bracket, if stack is empty or item is not matching, so it is, improperly formed. So which page it is? Page number 172 of your chapter 7. Checking bracket and parenthesis. Okay. So let's do another method. A small, another example for any idea what is a palindrome? Palindrome string or palindrome number, anything? Any idea on that? Oh, let me just save it. Palindrome. So palindrome is a string that is read in the same way, either forward or from backward. So A, B, B, A, if you read it from this side, left side, A, B, B, A. If you read this from right, A, B, B, A, it is the same thing. So this string is a palindrome string. This number 1, 2, 2, 3, 3, 2, 2, 1. Read it from left. 1, 2, 2, 3, 3, 2, 2, 1. Read it from right. 1, 2, 2, 3, 3, 2, 2, 1. It is the same thing from either you read it from left or you read it from right. So this number is a palindrome. So if I change it like this or this, So now 1, 2, 2, 3 from left, but from right 3, 2, 2, 1. It is different. Okay. So when you read it from left and you read it from right, both are the same thing. It means it is a palindrome number or palindrome expression or palindrome string. Okay. Otherwise, it is not a palindrome. So we can, I mean, it is not a must to use stack here, but we can use stack here. And the idea is, let me tell you, the idea is, where is my board? Yeah. Okay. Let's have an example, a demonstration that how can we use stack for checking palindrome. For example, user inputs me a string and says, check if it is a palindrome. So what I do, A, B, B, A. So when I start reading, I do it in half. First of all, I will make it half like this. Then I will push the first half on stack. I will read A, I will push A. I will read B, I will push B. Half is done. Now I will come to the next half. And I will read a character from here, B, and I will pop a character from stack. And I will see if both are same or not. If character from stack top, which is B, is same, whatever I am reading from the second half. So it means it is good. B equals B. Then I read next character A. I pop the next item from stack, which is A. Stack is empty. I get an A. So now I will see if this A is matching with the character which I read in the second half, and it was A right here. So A equals A, string is finished, stack is finished. So we found a palindrome. So the idea is we make the expression into half. We push the first half on stack, and then we start matching from the second half. So we read the second half one by one character, and every character we match it from stack top by popping one item out. So at any time the characters are not matched, the stack character and your other half string character. So it means it is not palindrome. That's the idea. Does it make some sense? For example, this is a stack. Another example for a string is A, B, B, D. A, C, C, D. I make it half, okay? And now I push the first half on stack. I mean, pushing the first half is not a must. You can do it otherwise, but I'm discussing the first half. So I'm pushing A, then I'm pushing the next character, which is C. Now I will read this half, other half of the expression one by one character. I will pick C and pop item from stack and see what is there. So they are matching C and C, good. Read the next character, D, and pop another character from stack, A. D and A don't match, so it is not a palindrome. So A, C, C, D is not a palindrome because reading from left and reading from right is different. It gives us a different string. So this is another application of using, palindrome, using stack, sorry. I mean, this is a simple example, but, for convenience, why not? When we have a stack already, so let's use it. From stack to do. Import everything. By the way, we just need push and pop. We don't need anything specific, I believe. Okay, so as you said that we need a class, we should make a class, okay? Palindrome checker. By the way, there is not much difference in the syntax if you use a method or in a class or without a class. Whenever you use a class, you have to take the name of class and then the name of method. When you have a direct method, you don't need the class name. Let's try it the other way around this time. Just method. Why not? Because I'm not going to use it as a class anywhere. So just a sample code. So palindrome checker. and put an expression in. Okay, so first of all, we will do the half. Okay, and how can we make a half? Length of expression by 2. Okay, so divided by 2 like this, right? If the length is odd, it doesn't matter, okay? Because the middle character will be read same if we read it from left or we read it from right, okay? So it doesn't matter if the length is an, the half giving us, somehow is there is an odd number of in number of characters. For example, length is 5, so half will be 2 or 3, okay? So an extra character in the middle, but it will not matter. You will see in the output it doesn't matter because palindrome output will not affect with the odd number of characters. All right, so let's start from our loop. So we have to let's make a middle point. So length or half length. Let's say it half length because this is middle, right? And how about let's say it mid, even better. Mid is length of expression divided by 2. So while let's make a variable I is 0 and while I is less than mid, because we have to, push the characters on the stack, right? So let's make a stack first, by the way. Stack.push expression of I. So this is what we need to push. So after pushing, I'm using while loop here, so I have to increment I with 1. Okay, so let's make a stack here. Stack equal stack of 100. All right, that's better. Okay, I mean, you can use the length of expression just like we did earlier, but for now, I'm just putting 100. Okay, so I'm putting the characters, the initial part, till midpoint on the stack. After that, we need to check if the length is odd. Okay, so if mid mod 2 is not 0. So if you are getting a remainder, not mid, sorry, length of expression. What I'm doing. If length of expression mod 2 is not equal to 0. So whatever is your length of expression, for example, length of expression is 4, then it will be 0. If length of expression is 5, which means 5 characters, so then mod will not be 0 because you are getting a remainder. You are dividing by 2, but you are getting a remainder of 1. So in this case, it means length is odd, right? So we are skipping the middle character because middle character doesn't matter. Okay, so what we do, we just go to the next point, I equals I plus 1. So what we did, we push the first half, and if the length is odd, only in that case we will increment I to I plus 1. If the length is equivalent, which is half characters here and half there on the left and right, both are same character, then this part will be skipped. Okay, but if length is odd, then we will skip the middle part. Okay, because it doesn't matter in palindrome. It will be read same way from right and left. So skipping that part, and now we have to match right here. Match the second half while popping items out of stack. Okay, so this is what we discussed. So while I is less than length of expression, we have to go to the end, right? So we will compare to the end part. While I is length of expression, we will keep popping the item from stack. So let's save it here. Character equals stack dot pop and then match. So if this character from stack is matching with the character in your expression at the ith position. So we will write a condition if ch equals okay, let's check not equal because it will return false quickly. If character is not equal to expression of I, which means any character is not matched. Some character is not matched. At that point, we can quickly return false. We don't need to check anything else. If one character did not match. If everything was, matching, so we will keep continue by doing what? I equals I plus 1. We will go to the next point. And then finally, if false is not returned, it means it is true. The expression is like a palindrome. Yeah. So in this part, we check the first half. If the length is odd, we skipped one character. If the length is even, this part will not be executed. And then we matched remaining part, the second half, by popping every character from stack and matching with every character from the second half. So here we are matching, doing this part. If at some point character didn't match, we return false, otherwise we return true. So let's call the method. Where is our stack? Okay, there. So let's call the method. What is the method name? Palindrome checker. And input some expression, for example, A, B, B, A. This is a palindrome. It should return true. If palindrome checker returns true, so print this is a palindrome expression. Else if, okay, no, else print this is not a palindrome expression. Okay, so if it returns true, this method returns true. So we print it as a palindrome, otherwise it is not a palindrome. Let's see. So we are inputting right here. We are not taking input from user. Instead, I'm putting a string right here to check. So this is a palindrome because A, B, B, A is read same way from right and left. It is read in the same, the reading is same from both sides. Let's change a little bit. So now it is different, okay? So this is not a palindrome expression. So yeah, so we divided the length into half, half. First half we pushed on stack, and second half we matched with stack by popping every item one by one. And then we called it, and this is an example again for stack, for using stack. You're not bound to use stack in here. You can use array, you can use list, everything is okay, but we use stack, which is also good. Yeah, okay. Okay, so let's take a 10-minute break and then implement the final part of our code. And we did the balancing, and now we will do the coding part for this, where we will convert expression, infix expression to postfix. Yeah, that's the final step. Couple of lines of more code. I will try to make it simple, and then after that we will discuss the final assignment part, which is really a small thing, and we are done. Okay, so let's take a quick 10. My stopwatch. By the way, if you have any questions, you are more than welcome. Start. Right. All right. To the final part of implementation. Not this. Okay, so we are going to work for this. Converting infix expression to postfix. So we just keep the steps in mind, which we have from our book, and on the same lines we will implement. I can just keep it open for myself as well. Yeah, so these are the steps. The page, which page it is? I don't know. 177. Okay, so page number 177. Let me just open it up for myself. Okay. So we will be using postfix expression, which will be empty initially, and an empty stack, which will be having later left parentheses and operators. Whenever we encounter right parentheses, we will pop the material from stack until we get a left parenthesis from stack. Not all the things from stack, okay? But this will be done when we encounter the closing parentheses, right parentheses. And other than that, we just have to read the expression and put the operand on postfix expression, and then we will, see the priority. Whenever operator comes, we have to match the operator with the operators on stack. If the operator on stack have higher priority than the operator we are reading from the expression, then we will pop the operator from stack and put it on the end of postfix expression. So we will follow on the same lines. It looks a little bit of time taking, but the idea is really the same. We are just using whatever we discussed. No, where is my editor? Right here. So let me just open up a new copy of file, a new file. And import from stack to do import stack. Okay. No, import star. Sorry. Let's save the file. We are doing infix to postfix. Okay, infix to postfix. Sorry. By mistake, I just did a text. We don't need a text file, right? Can we rename it somehow if it becomes Python file? No, I don't know. Let's save it again. Infix to postfix in our downloads dot Python. Okay, so let's start from, okay, first of all, what I will do, I will create a set of operators on which we will be working, right? So create your operators. We can, set contains all the elements which are distinct, okay? So here we will be using set, and we can put our operators plus the basic operators, right? Multiplication and division. All right, These if you want, you can also use exponent, this exponent. So exponent has the highest priority. Okay, so this operator has the highest priority. So this is set of operators, and then we can create priority list. Priority list, and in that I will be setting you know, operators priority. For example, you know, these operators have same priority, then these, and this one has the highest priority. So what I will be doing, I will put a, you know, character operator, and then I will set the priority for it. For example, plus has a priority of 1, and in the same way I can put for minus, sorry, this is minus operator, it has priority of 1 because plus and minus have same, you know, precedence. Then I put another operator, for example, division, and division has higher priority, so give it a number 2. Oh, not, I am giving it a number 2. And then steric has the same priority like division, so give it a number 2. Exponent has the highest priority, so put exponent and give it another higher number, which is 3. So by checking these, you know, these numbers, I can check, you know, what is the priority. Okay. So, I mean, this is one way of checking the priority by just checking the numbers. So let's make a method. Again, you can make a class, but I'm just making a method in fix to postfix. Yeah. So it is going to take an expression, and we are going to convert that expression to postfix. Okay. So the first step should be start with an empty expression. Postfix expression has nothing. Initially, it will be empty, okay? And then we need to traverse and pick all the characters from expression. Okay, so we have to run a loop, and we have to see each element in expression. And then we have to apply all the rules, whatever we discussed from the book. So if your character is not in operators, so it means if it is not in these operators, so this is an operand, okay? And we have to put the operand in the postfix expression. We have to append the operands in postfix, okay? This is the first step. So if character is not operator, in that case, what I will do, I will use my postfix and I will append whatever the character is. So whatever character comes, if it is not operator, I will append it in postfix expression. Okay. So this is the first step. Otherwise, we have set of condition. Else character can be, you know, it can be an opening parenthesis, just the left part, because left part we need to push on the stack. And when right comes, we have to pop from the stack. So we have to check if it is an opening, then we are pushing it on stack. So stack, I have to make a stack as well. Stack dot push this character. But before that, let's make a stack. I can make a stack right here. Stack equals stack of 100. Okay. By the way, you should make a stack according to the length expression, length of this expression, instead of just putting a random number, right? Okay. But I'm making it large enough so that expression fits there. So if character is opening parentheses, then push it on the stack. Yeah. Otherwise, character can be the closing, right? Check it. If character is a closing parentheses, in that case, we have to what we have to do. We have to pop the items from stack and see whenever we encounter the left parentheses. Okay, so until we encounter left, we have to pop every item. When we encounter left, we have to stop. And whatever we will be popping, we have to append that. We are not wasting that part. We have to put that part in postfix expression, append that right here in the postfix expression. So on the same rules, if character is opening, then while not stack dot is empty, when until it is not empty, and stack dot peak is not equal to this left part. So until the peak is not the left part and the stack is not empty, we will continue popping the items out and putting it in postfix, appending it in postfix expression. So this is what we will do here. We are going to append. Okay, so postfix plus equals to stack dot pop. Yeah. So until we don't encounter the left and stack is not empty, we have to make sure stack should not be empty. Till then, we will keep popping. So when we encounter the left parenthesis, we will stop. Okay, we will keep popping and we will keep appending it in the postfix expression. Okay, so that part is done. Okay, else if okay, stack dot peak not equal to this. So when stack peak will be this character. At that point, we will do a stack dot pop because we are not adding parentheses in the postfix. You know, your postfix expression has no parentheses. So that's why I am adding this line, because this line will delete slash pop left parentheses. We don't need left parentheses. So we will keep checking the stack until the top is not opening. So until the top is not opening, we will keep popping the characters. We will keep adding the characters in postfix expression when the top becomes left opening. In that case, we will just delete that opening because we don't need it. We don't need it in postfix expression. So just remove that, but stop now. Okay. So after that, even if stack has more elements, stop it. You have handled the opening and closing. Now read the next, the next character and then deal the condition according to that. Okay. So far we handled if character is not operator, add it on in the postfix. If it is opening, push it on stack. If it is closing, do that. Now we are putting another condition, which is almost the final else. So put a loop while not stack dot is empty and stack dot peak. So this is the final long condition, not equal to this. We have to check the priority. We have to make sure in this case we are checking if this is an operator. And when the operator comes, we have to check the stack. If stack has operator who have higher precedence than the one we have in our, in our this variable. So that's the final part. This part let me just share the book. That's the final part I'm adding in the code. What is that? This part. On encountering an operator, pop off the stack operators who have equal or higher precedence and append them to postfix expression. So this step we are doing now. Let me put it back. I mean, I know it looks a little bit of complicated, but I mean, this is how we do it. So while not stack is empty, again on the same point, and stack dot peak not equal to left part, and another condition. And priority, we have to check the priority list of character. Whatever character we are reading, that character has a less or equal. It means the stack character has higher priority. So we have to check that from stack priority of stack dot peak, because peak can tell what is on the top. So whatever is on the top, we will match the priority of that item with whatever we have in hand. Okay, and if this condition is true and the precedence of operator which is on the stack, which is on the top, has higher precedence, pop it out. Okay, higher or equal. Okay, pop it out and add it in the postfix expression. Okay, so this step we need to do. Okay, stack dot like this. So I hope that this is a complete condition. So in this case, we will add postfix plus equal to whatever we will pop. So, and after popping the element, we are adding that in the postfix. Okay, and finally, when the loop will end, we have to do the final step from here again. Push the scanned operator on the stack. This part is left in the code. So let's do that. Push the scanned operator, which is ch, on the stack. So let's do that. So it means come out of the loop and do stack dot push ch character. Yeah. So we have pushed that character on the stack, which came later, and after that, for loop is ended. While, yeah, so we have added all the condition. Finally, we just need to check what else is in the stack. Pick that up, pop that up out, and put it and append it in postfix expression. This is the last line of the algorithm. So while not stack dot is empty, make it empty. So if stack still has some items, we have to get those items and add them in postfix expression. So stack dot pop. Yeah. And finally, it should be having the complete, postfix should be converted. I mean, infix should be converted to postfix at this line. So return your, we can return the postfix direct. Yeah. So postfix expression, we can return right here. That's it. Let's call the method and see. And if there is some bug, we will do a debugging. Do pass an expression, for example, let's pass the same thing, whatever we have here. Okay, so 4 plus 5, let's do something with parentheses. 4 plus 5 times 6 minus 3. I'm adding right here. You can take input from user. 4 plus 5 times, what was that? 6 minus 3. So this is an infix expression, but we want the postfix. So let's print. So it should return as postfix expression. Because it is returning the expressions, we are printing it. Okay. So it returned 45. I don't know. Let's see the output right here. Okay, so 45. By the way, it has parentheses there. A little bit of problem. So 45 plus 6, 3 minus Derek. Oh, something is wrong in my code. It should remove the parentheses, by the way. Okay. Let's pass something without parentheses and see if it gives the right output. So 4 plus 5 times 6 minus 3. Without parentheses, okay? It should return 4, 5, 6, this one, whatever we have here. 456 star plus 3 minus. Okay, so this output is okay. Without parentheses, the output is okay. With parentheses, it's not okay. So we have to see what is the issue there. But this was kind of a, little bit of more advanced code, I would say. I mean, I added all the steps, but push on the stack, pop the stack until this is encountered. It should not have, the final expression should not have the parentheses because we just pop it out and we just don't add it. Let me just see, there should be a little bit of mistake or small bug. Okay, so let's go through the code. We have empty postfix expression, we have empty stack. Whenever we read a character from expression, from our mathematical expression, if it is not operator, we add it in postfix, append it in postfix. If character is opening, left parenthesis opening, we push it on stack. If it is closing, yeah, somehow the problem is here. I believe so. Okay, let's see it later. So this part, so all the conditions are here. This part is whenever we check the precedence, and once all the stuff is done, we see whatever is on the stack, we pop it out and append it. So let's just go through this part. Give me a second. Here. So basically, what else? What is? Let's see why the parentheses are still in the postfix expression. I mean, parentheses should not be there. That's the issue. So, mhm. So I'm just looking into the code to make sure that why the parentheses still appear. I push the opening part, left parenthesis, but when right parentheses come, I pop it. And I also pop the right parenthesis. Okay, so, well, node stack is empty. And stack peak is not this. Add this on stack. I mean, looks okay, but output is not okay somehow. Why it is appending the parenthesis part? I mean, we have to debug it somehow. That's in this way. Let me just see what it is doing. There looks like some problem. What is that? So strange output. Okay, sorry. I'm just giving, it's not taking input right here. So I'm just entering an expression here. So I have to change if I have to, see that different output. So I have to change right here. Okay, so let's try again once more. Why the parentheses are there? I'm kind of, yeah, it's still there. It doesn't remove these parentheses. if character is closing. Hmm. I really have to debug that. Why it's let's make it very small and debug it. Let's do like this. 4 plus 5 and see the output. Yeah, so yeah, this is a good point. Let's see why it is not removing my parentheses, because the idea is that don't postfix operation expression doesn't have parentheses. So that's the beauty of postfix. Let's see. F11, F10, F10, F10. Okay, character is opening. It will be pushed on stack. Wow. Yeah, so I am doing a mistake here. You see, it added it right there. So that's the problem. Yeah, I am missing a condition. Let's do that. So it added right there. So that's why we have it in the expression, because in my code, I am adding it. I'm just adding the expression. So what we should do, basically, we start for checking the expression, each character. If character is not in operators, in that case, if character is not in operators, okay. So in that case, it adds that in the postfix. Yeah. So that's why my condition is, um, not correct. Because correct, if character is not in operator and character is parenthesis, so parenthesis comes and it says it is not there. So that's why it adds it in postfix. So let's add the parentheses right here, because parentheses are also like our, operators. Now it should work. So this condition was not getting correct. So it was checking if character is not in operators, and my parenthesis was not in operator. So it was adding it in postfix expression, final expression. So now it should do the final correct part. Yeah, you see 45, 45 plus. Now the output is okay. Yeah, so that was the missing thing, and the condition was not getting true. So let's change it and add the expression from the book again. What is the expression? 4 plus 5 and multiplied by 6 minus 3. Let's add that. Multiplied by 6 minus 3. Yeah, 45 plus 63 minus star. 45 plus 63 minus star. Now it is good. Now the output is good. And we just followed exactly the same steps, which they are showing in example, and which they are actually showing right here. The same steps in the code. So again, we applied, we have now seen another implementation and application of stack where we can convert infix to postfix. So final step for, first step was balancing, then, it was converting, and now final step is evaluation. So evaluation is really brief, just 3 steps. Did I get a message? One moment, guys. Where is my chat? Yeah, okay, so you can share your screen. Let's do it together. Priority list. Yeah, so add the parentheses in priority list. Okay, so there is an error.
Yeah, somewhere on this line, but I can't pick it out.
What is the error?
It says key error none.
Okay, so key error none. One moment. What is the next line after that? However, you are getting the error at this line. Okay, so yeah, this looks correct. So the error is exactly on the same line.
What do you mean?
I mean, on line 24, line number 24, you are getting the error.
Yeah.
Okay.
So I don't get the error when if I take this out. I only get it when I use multiplication. So if I take that out.
Okay, in that
Never
case,
mind. Never mind. It is
the
still going.
condition. Okay, so the condition actually. One moment, let me just see. It says while. So somewhere
Actually,
it's showing.
it works when this is what I did. I think when I was following along with you, when I did it like this, I think it works like this. Yeah, so I
Oh
got
yeah.
45.
Can you add the parentheses on your method on top first? In your operators. Oh, you have that. You have that. And then 1 1 2 2 3. Yeah. I mean, I am using the same condition. One moment, let me just match it with mine. Sometimes it is really a, small bug. We always see these bugs. And priority, I'm checking with the corrector. If stack priority is higher, in that case, I add. Oh my God, it's exactly the same thing. Can you please send me your code file?
Yeah.
Yeah, that's the best way. It takes less time then. Yeah, I can check it on Teams chat.
Yeah, I just sent it to you.
Yeah, got it. Download. Okay, there. Let's open it up. It's mine, and I will open your here, right here. Okay. It is working on my side. You see that?
No, I can't see your screen.
Oh yeah, sorry. Let me just share it. It is working exactly the same way. I just opened the file and let me just roll it back. I just added that part in right here like this, 6 minus 3, the same expression which I was trying to do. And now I see the output right here.
Yeah. Okay, maybe it's just wrong.
Maybe
Wrong with like my stack to do.
Yeah, exactly. So yeah, just try to see where is your file, and also close it and open it again. Maybe it
Okay.
works sometimes,
Okay.
Yeah.
Yeah, I'll play with that so we don't have to.
Yeah,
keep
because
going
it is
on my
working
stuff.
on my side. Okay. Sometimes reopening the same, code works if there is, some kind of issue. Okay, so the final thing, which before, ending the class today, assignment exception with stack. So this is really a small thing, I sometimes refer you guys to W3 schools. Let's open it up, right? From where we can search. Not here, I don't know. One moment, let me just Google about exception. So we have, at some points I used raising the error stuff. Exception handling. When an error occurs or exception, Python will normally stop and generate a message. But whenever we want to handle that error, we can raise an error. For example, try block will generate an exception because X is not defined. Print X, so X is nothing. So if I run this code, an exception occurred. It shows me that message. The built-in exceptions are done using raise, try blocks, raise for raising or throwing an exception. So this is what your assignment says, that throw an exception whenever there is an issue. So for example, raise an error and stop program is if X is less than 0. So if X is -1, which means it is less than 0, raise an exception. So I will put a condition: if X is less than 0, raise exception. Okay. So in this case, exception will be raised. So this is an exception. Sorry, no numbers below 0. So this is how exception works, that your program doesn't break. Instead, it shows you that there is some problem and what is the problem. So you have to add the exception part in your stack class to throw exceptions if something is pushed onto a full stack or popped off an empty stack. If stack is full, we cannot push anything more. If stack is empty, we cannot pop anything out, right? So let's raise an exception there. In the code. It's my code, yeah, there. So let's open up the file. I'm not sure if I have that exception. Yeah, we have the stack class, right? So we can add the code there. Yeah. So they say that whenever raise an exception if there is some problem. Right now we can, we are returning if it is full. And we are pushing without checking if it is full. So we must make sure whenever we are adding an item or pushing an item on stack should not be full. So put a condition here: if not, or if, self dot is empty, is full. If your stack is full, already full, so raise an exception. This is what they say. This is what your, assignment says, that throw an exception if something is pushed on stack which is full. Okay, so write a test program that demonstrates that revised class properly accepts item up to the original stack size and throw exception whenever an extra item is pushed. So change a little bit into your stack class. For example, one thing can be like this: if self dot is full, raise exception and write stack is already full, like this. This is one part. So similarly, you can raise exception if stack is empty. So you cannot pop any item out if stack has nothing. Okay, so put a condition here to check if stack is empty, just like I added stack. If stack is full, print or throw an exception using raise exception, so that user know that, okay, stack is already full. I need to, remove some items instead of adding more item, or I should change the size of stack so that I can add more data. Okay, So in similar way, add something for pop so that you cannot pop anything out if it is empty. So add that condition there. Yeah, that's it for your assignment part. So you can go ahead and go through. If you have any questions about the exception part, I can definitely assist you on that. Let me know, I will help you. But a couple of examples are here. For example, raise an error if x is not an integer. So x is a string. So if not type of x is integer, we can raise error. Error type is, this type error. Only integers are allowed. So in Python, there are different type of errors which we can raise. So depending on whatever you want to raise, you can put. So in general, we can use exception for a message. So exception class handles, already many kind of exceptions for us. This is a built-in, class of Python, which we use for exception handling. So exceptions handles your issues of the code in a good way and reminds the user, okay, you are doing a mistake, stack is full, you are pushing more data there, something like that, okay? So yeah, so this is what you have to do in your assignment. Change a little bit there, revise the class, and then, write a test program to see that you are pushing an item into stack and it is giving you an exception, raising an exception that it is already full and you are pushing more data, okay? So that's it. Other than that, we have worked on the projects, whatever you have in the module, so it is all completed. Yeah. Yay, next week is for about review, a little bit of new work. Major will be the review part, whatever we have done so far from chapter 1 till chapter 7. Okay, so any questions, anything, guys, you are more than welcome. I am available for extra time as well if you need at any point. You can send an email, you can text me on Teams, and I will be there for your help, okay? So we can have one-on-one session. So yeah, so well, that's all for today. I wish you a very good night. Take care, guys.
Thank you, Professor. If you got a second, I do want you to look at my code too.
Yeah, sure. Make sure that I am here available for next 1.5 hours. So I am there for you. If you have any kind of question, just let me know. So you can share your screen. Good night. I stop mine and you can share yours if you want to share the code.
Yep, there it is. Okay, I apologize. Trying to get the right monitor. So
Okay.
my output is a little different.
Okay, can you run the code? Okay, I see 9 there. That is the output, right? Can you run the code again?
Yes.
Oh yeah, really?
I tried to look over it and
yeah,
I
let me
couldn't
just
quite. Okay.
let me just have a look for character in expression if it is not operator. Okay, if it is opening, push, if it is closing, pop else. Wow, it looks okay. For loop, while loop. Plus. Okay. Why it is not, showing the exact output? Can you send me your file?
Yes.
did.
See, I'm trying to figure out where to send it from here. My
Okay.
window changed a little bit.
Yeah, no problem.
Oh, you know what? I can send through Teams.
Actually, if you open up your team, you see a chat there, chat box there, activity chat. Oh yeah.
Okay.
You send it you send it somewhere else? Oh no.
No,
Right.
I haven't sent it yet.
Yeah.
This is it right here, right? Yeah.
No, not here, not here. Everyone will see that. From there, you can send me on chat. Activities for everyone.
Oh, okay. I see. Okay.
Yeah. Right there. Yeah. I didn't get the file.
Sorry.
Did you send the file?
Yes.
Why I didn't see it? Oh, I think you have to press that arrow down.
Oh, I'm sorry. Yeah, that was my bad. I'm sorry.
Yeah. No, I got it. Yeah. Yes, there. Infix to postfix. Okay. So let me open up. File open. I think this is yours. Yeah. One. Plus and minus have same priority, so it should be 1, 1 for them. Multiplication and division have same priority. It should be, what is that? It should be 2 for multiplication and division. And then for exponent, that is the highest priority. So it should be a number higher, like 3. Okay. So plus minus same priority, to multiplication, division same, and exponent is the highest.
Oh, okay.
And now if we call the method, okay, stack, and then you are using stack class, right? Oh yeah, so there is a mistake. You see that there should be a comma right here. You see, everything is separated by comma because everything is a separate character. I think it should work now. No, still not. That was a typo right here. Okay. So by the way, oh yeah, because you are not printing it, right? So print it, print the result. So you are getting the output, but from here, but you are not printing it. So either you can save it somehow, like a result equals from this method, and then you can print the result like this. Okay. So now you should be able to see it. Yeah, there. 45 plus 63 minus star. Good. It is there. So basically you were calling the function. So function is returning expression, but we are not printing anything. So we should print the result. So what I was doing the same thing, you know, in the class. I don't know. Maybe I closed that. But I was using print right here, like this, directly. Okay. Yeah. So it's okay if you put exactly, I mean, the same function, you know, method call inside print, it will print, or you save it, just like I showed, in a variable, and you print that variable. Both are same. And yeah, so make sure that you remove this bug, put a comma, and then set the priority list like this.
Oh, I can't see your screen. I could just
Oh, you can see my screen?
No, I can't,
Oh my
because I'm
goodness.
sharing my screen. Oh, there we
Oh,
go.
so can you see now?
Yes, yes, ma'am.
So basically, I did a couple of changes. Let me roll it back. Okay, so I have this file. The first issue is this comma.
Mhm.
Okay, then
Okay,
this plus has highest priority, minus and plus have same, so it should be 1 for both. Multiplication
okay,
has 3, division has 3. Okay,
okay,
then add another if you want, for example, exponent. It has the highest. Okay, not 3 actually. You can take 2 because 2 is higher than 1. So multiplication has 2 and division has 2. Exponent has the highest, so it should be 3, like this.
okay,
Yeah, so same priority plus minus, same priority for this, higher priority for this.
okay,
That's one difference, okay? And after that, we are not printing. So print the result like this, you know?
right,
Yeah, so now it should print. Yeah, it is printing. So
okay.
either you
I see.
print right like that, or you know, put the results, put the result in a separate variable, and then you print it.
Right,
Like this.
okay,
Yeah. So it is, you know, it is working fine. A little bit
Yes,
of
but
issue right here. So do you need this file or you will fix it yourself?
I'll fix it myself.
Oh,
I'll
okay,
fix it
great.
myself.
Okay,
Thank you,
wonderful.
ma'am. I see
Okay.
now.
Okay, any other questions?
No, ma'am. No.
Okay, great. So I wish you
Thank
good
you,
night,
Professor.
take care, and see you next week.
Yes, ma'am. All
Okay,
right, good
take
night.
care. Bye.
Bye-bye.
Bye.